This is the continuation for the L2 loop troubleshooting. In the last session, we have discussed about the states of a spanning tree. So suppose if you have a spanning tree running in your topology, then what are the states they changed, and if you have layer 2 loop in a network, then how could you troubleshoot that? I have one topology here that today also I will check this topology. In this particular topology, and it's very simple topology. You can see switch 2, 3 and 4. So if you want to check who is the root in this particular topology, it's very easy to identify who is the root, and you have to execute the command show spanning tree. So suppose if I go to switch number 2, no spanning tree instance exists. So this is flat diagram here. What I have to do, I have to initiate the VLAN. So by default, all the ports are in VLAN 1, and I haven't initiated that VLAN 1 on switch number 2. In switch number 3 and 4, I have few VLANs, and this interface E0/3 is trunk. So let me show you the configuration for E3 and E0/3, and let me make all these interfaces as trunk port on all the switches. So what I can do, I can go to switch number 2 and I can make switch number 2 as a So I'll go to the interface range and I can select 0/02 1 2, and here I can use switch port encapsulation, switch port trunk encapsulation.1q. So once you'll enable this command, then you can type switch port mode trunk. Obviously no shut you have to do. Likewise in the other switches as well, switch number 3 and switch number 4, I'll enable the same command. The switch number 3 has interface 0103. So I'll go to switch number 3, 0/1. I can take a range as well, 0/1 to and E0/3. Switch port trunk encapsulation.q. Switch port mode is trunk. So the mode is trunk, and then the no shut. Likewise in the switch number 4, I can take the interfaces E0203 and 10. So in the other switch I can take like interface E0/2, so I can use a range command 0/2 E0/3 and E1/0, no shut. Switch port trunk encapsulation.q. Switch port mode trunk. Now in this switch, I think in switch number 3 or 4, I have enabled some debugs. You can see in your output, show debug. Yeah, I have enabled one debug ICMP, some other feature debug. So that's why I'm getting such type of logs here. You can see such type of logs here, that they are getting some duplicate address. So actually I enable IPv6. So if you have any duplicate address, you will see in this particular output, and the counter will come here. Okay, I'll come to these things IPv6 in upcoming classes. and they have duplicate address in VLAN 30. So if you go to the VLAN 30, it will show you that you have duplicate address here as a DAD. Okay, duplicate address detection, and if you check show log for that, this way you are checking the logs as well. So in the logs you will get all those, if there is any group change or something like that, you'll get all those things. So the logs you will get like this, and so on. Anyways, I am focusing on a spanning tree case here, where I have to check who is the root. So if I go to switch number 2, and if I type so spanning tree, it is telling that this is the root. So this is my root, and we already know about that, what is the port roles. But again, in the upcoming spanning tree class, I'll show you how they are electing the roots and who is the root port, who is the designated port, how they select the blocking ports as well. So the optimization for that if you are not using a port, you simply shut down that port. If the ports are going towards end devices or terminating devices, you can use port fast. Apart from that, if you have loop, then you have other optimizations. So what are those optimization you can use? You can use these features. You can use loop guard, BPDU filter, and root guard. So what are these features? That suppose if you enable loop guard, now this loop guard and UDLD, they will come hand on hand. So maybe I shared one blog that in that blog you'll find a diagram that where you have to enable loop guard, where you have to enable root guard, BPDU guard where you can enable UDLD. But what this loop guard will do, that when it stop receiving BPDU, it puts that port into the inconsistent state. So what does it means? Loop guard is nothing but loop prevention mechanism inside a STP domain. So what they are telling, that suppose this is one port, this is in the forwarding state. If this port is in the forwarding state, that means always he will send the BPDUs, and obviously it is receiving the BPDUs as well. So a spanning tree, they are sending their hello packets, I think after every 2 seconds. So it is getting the BPDUs as well, and it is sending the BPDUs as well. Both the things this forwarding port is doing. Suppose if this particular forwarding state or switch state, when it stop receiving BPDU, so if they are not getting any BPDU ingress, or if they are not getting any BPDUs, they move that port into the inconsistent state. So what does it means? That suppose if you are not getting BPDU, and there are chances that you are sending BPDUs with some mark, suppose HH. Now what switch will expect, that because you are not receiving the BPDUs, means maybe in future if you get HH, you are not able to understand the same BPDU, and maybe you have loop in a network. Let me give you the other good example. So suppose this is my switch, this is my switch. They are connected back to back, something like that. Now how switches, they identify that there is no loop? Because they block one port. So once a port is blocking, they are getting the BPDUs, but they are not sending the BPDUs. That is the characteristic of a blocking port. Now suppose if a port will not get a BPDU, that means there is chance of getting loop. Okay, because if you are not getting the BPDU, that means you are not able to identify the BPDUs, or in future if this link will go down, you will not move your status from blocking to forwarding state, because you are not getting the BPDUs. So you are not getting the BPDUs, that means that you are not aware about the topology, or about what are the things that is happening inside the network. Okay, so if you are not getting the BPDU, this feature will move that port into the inconsistent state. So if you check the log, you will find that port is in the inconsistent state due to loop guard. You will get such type of log. Now, the second feature is the BPDU guard. So let me go to that feature, the feature number 2. Now, BPDU guard will error disable if BPDU receive. Now, this condition is true for edge ports. So we know that in the edge ports where the PCs are connected, these are in the port fast. So if they are receiving some BPDUs, that means what? If you are making port fast a particular interface, that means they are all the time they are in the forwarding state. Still, if they will get some BPDUs, they will move that port. Actually, they will error disable that port. Let me go to the other variant, that is the BPDU filter. So there is some difference between BPDU guard and BPDU filter that we can identify here. Let me go back. You can see here in the BPDU filter, what BPDU filter will do. Again, this is with respect to edge port, this is with respect to edge port. Does not send or, actually it should be or, send or receive BPDUs, effectively STP disable on that port. So what they will do, simply they will cut off that interface, means the interface is now disabled. So this is very aggressive optimization. If a port is not sending or receiving BPDU, it will, you can say it will shut down that port, something like that. It will move this port into the error disable. So if a port is in the error disable mode, there is error disable auto recovery feature that is set to maybe 30 seconds or 60 seconds. So that port will come automatically online after 30 seconds or maybe 60 seconds. But if you apply BPDU filter, then that port will be permanently disabled. So it will not come back online. So this is much aggressive feature than the BPDU guard, and both are applicable for the edge ports. Then finally root guard. Root guard feature is simpler than all the other features. Why? Because this root guard feature, what it will do, that if you don't expect any other devices to become root, then this root guard will come into the picture. So for designated ports, it is applicable for the designated ports. This is my diagram. This is root port. This is, suppose this is the root. This is designated port. This is root port. This is designated port. This is block for the moment. You can apply this feature for designated ports. So what will happen, that because this is the root and this is the designated port, so if some other switch, if they come with low priority, and suppose it has priority 4096, so lower is better. If it is coming with a priority of 0, it will become the root in a network. So if the switch will get such type of BPDU, this port will move to the inconsistent state. Okay, so inconsistence or error disable or inconsistence, but this is disabling the BPDU. This is with the edge port, this is with the edge port. This you can apply in the non-edge ports for non-designated ports, and this is for designated port. So this is the optimization. I will share one diagram with you guys. That diagram is self-explanatory. If you go through that diagram, you'll come to know where you have to apply which type of feature. But these two features you have to apply into the edge ports. Be very careful while you are applying this feature. So try to use this one and it will help you. How you could apply all these features, you can see that it's either you can apply globally or you can apply interface level. So it depends upon the criteria, what type of security you have, what type of services you want, or what type of optimization you are doing inside the STP. So you can use these features. So for guard loop this, for guard root, these are very identical type of features. Let me show you one of the feature. Let me show you this feature, guard root. So how you could apply this guard root feature. I have some devices in my topology, so let me open those devices here. What I will do here, because this is the root, I'll take one more switch. I'll take switch number 6. Let me connect switch 6 with switch 2. And because this is number 6, start. Switch is 6 is here. Let me increase the font size. So what I'm going to do here, we all know that switch number 2 is root, and this particular switch, so I'll go to switch number 2 first, and I'll enable one feature, that is the root guard, and the interface that is connected with switch number 6 is, I think, E03. So this is the interface E03, and here E0/0. Let me go to switch number 2 and interface E0/3, no shut. So by default they are in VLAN 1. Interface VLAN 1 do no shut as well. Okay. So interface E0/3, what I will do here, that spanning tree, and you have options. So you can use BPDU filter, BPDU guard, you can use guard, and if you type guard, then you have option of loop and root. So suppose this is root for this particular interface. Spanning tree 2, you can see this syslog message here. It is telling that spanning tree 2 root guard config change root guard enable on this interface. So if I check this interface, show spanning tree interface E0/3. Okay, let me show you both the outputs. So detail, root guard is enabled on this particular port. Okay, let me go to the switch number 6. Here I have switch number 6 on interface 0/0, no shut. Interface VLAN is 1, no shut. Okay. Now on this interface, what I will do, I will make this, I'll try to make this switch as a root. So for that you can type one command like spanning tree root. You can check the options here. So VLAN 1 and priority, you can give priority as 0. 0 is the lowest priority. So what will happen once I will type this as 0, it will try to become a root. Let me press enter here and let me see that output here. See, spanning tree root guard block. The root guard blocking port 0/3. If I check show interface E0/3, it is connected. Now it is showing connected, but it moves to the error disable. Show log, we can check the last log. So 0/3, you can see here, block root guard blocking port 0/3. So that means that this particular switch, this particular interface is not taking any BPDUs in this direction. So 0/3, it moves to a root card block straight. Now what I want to check here, one other output here. So you can check this, show spanning tree inconsistent port. That is one important output. So show spanning tree inconsistent ports, and it is telling that 0/3 is root inconsistent. So that is one validation criteria you can check. Okay, these are the way you can enable these commands and verify these commands. It's easy. Now what are the common layer 2 instability states? So you can get this MAC flap messages, or you can get some messages related to error disable or root inconsistent, like that. These are the messages. We are also familiar with these messages. So once you have these type of messages, your CAM table will start fill up. So what you have to do, that you have to check your layer 2 instability. Why the layer 2 instability is there? You have to find the MAC address. You may have loop topology in your network, means one port is by mistake connected to other switch, that switch is again connected to other switch, or you may have some misconfiguration. If you do all these optimization, you'll come to know that most of the chances that these 4 commands will fix the issue. Okay, and other issues you will get that once you track the particular MAC address, you'll find that that they are showing that by mistake this host is learning on 2 interfaces, means by mistake I have connected back-to-back interfaces, means I have created one loop inside my topology. Yeah. So this is about this layer 2 instability and how you can check and how you can troubleshoot. If you have any, one question is there, what is the use of UDLD and when we are using the UDLD? So let me walk through one blog I have, that is GigaNetworkers blogspot.in. UDLD is nothing but a unidirectional link detection. That is a fix of one of the very standard type of problem in the optical cable. So what is the problem with the optical cable? If you check any type of optical cable, you will find that those optical cables has either LC connection or maybe SC or LR or something like that. So whatever connectors you have, either it is short range or long range, they have 2 interfaces. So one interface is something like RX, one interface is TX. This is very specific with the optical cable. So RX and TX, sometimes what happens that one of the interfaces stop working. So if you have such type of issue that one of the interface is not working, at that time you can use, in case of optical fiber type of topology, you can use unidirectional link detection. Unidirectional link detection means that you are detecting if one of the link become, or one of your cable become unidirectional, something like that. So that means RX and TX you have, and one of the receiving or transmitting is not working properly. So you can use UDLD feature. UDLD feature will aggressively check these interfaces that they are forwarding unidirectionally or bidirectionally, something like that. So both RX and TX are working or not, they will check and they will tell you. So that is the use of UDLD. We want to study more about UDLD, you can check here in this blog. But let me show you the configuration parameter and the optimization for this STP loops. Here you will get some information about UDLD and all the other features that we have discussed so far. This is the topology I want to tell you that what happened in your network, that your topology will be like this. So you have distribution switch 1 and 2. These distribution switches are connected with the access switch. Access switches are connected with the end devices. So in the end device side, you can use BPDU guard and port fast. For access switch to distribution switch, you can use UDLD, you can use loop guard. For distribution to distribution switch connection, you can use UDLD, because obviously this connection must be optical connections. So this is the standard Cisco parameter that you can use. So if you are not using such features, you can use those features. If your switch is connected with other switch, you can use root guard, or you can enable root guard. So this is the standard format to use this. Okay, so that was one question. That was good question. But anyways, in the feature classes, I will explain this UDLD and basic stuffs and configuration of UDLD, how you can configure UDLD. Anyways, if you go to this particular link, you will come to know that UDLD has two flavors. Either they can run as a normal or aggressive mode, and to enable this UDLD is very easy. You can go to global configuration mode, you can type UDLD enable. If you want aggressive mode, you can type UDLD aggressive. That's it. Now the second topic is how to take a span, how to take packet capture in your layer 2 switches or maybe layer 3 switch. Now in this case, this is a robust topic, and in coming 2 classes probably I'm going to explain this packet capturing things, how you can take captures, how you can use Wireshark to filter those packets, etc. But in this particular class I'm going to show you you can say that very simple type of packet capturing, or the span. Span is nothing but switch port analyzer, or you can tell this as a port mirroring. So we can mirror a port. So suppose I have one topology where my PC, whose IP is 192.168.1.11, it is connected with switch on interface, suppose F1/1, and other side I have one interface that is F1/2 that is connected with router whose IP is 192.168.1.1. What I want to do, I want to ping from this PC to this router, or maybe vice versa, from this router to this PC, and I want to capture all the packets for that. So what I can do for that, which interface actually I want to capture. Suppose I want to capture this interface. So here I can use a capturing, this will be my capturing interface. So this is my source for capture, and where I want to send that frame. I want to send these frames. So with the help of this span or port mirroring, I will copy that frame, and that frame I will send to this destination. So my source is something F1/2, and my destination is something F1/1. Now the important thing, that in this PC I have already installed Wireshark. It's very easy and free tool. You can download and install in your PC, and Wireshark is on. So Wireshark is on with respect to this interface in my PC. Okay. So once I will send the packet, one copy will come here. Okay. Okay. So that is the thing I am explaining here. So he asked what is port mirroring. Port mirroring and span are both the same thing. So what you can do in the port mirroring or the span, that suppose if you want to capture this traffic that is coming to this interface. So interface F/1/2, if you want to capture traffic coming into this interface, or suppose VLAN 10, if you want to capture traffic inside VLAN 10, what you can do, you can make a copy of that traffic. So whatever traffic that is coming inside on this interface, make a copy of that, because those are the frames, and those copied frames you can send to the destination where you have installed the Wireshark. So you can check those frames inside the Wireshark. Obviously, for this purpose, you need some source to whom you are copying, and you need a destination where you are sending the copied frame. Okay. So in this case, what I'm going to do, suppose F1/2 is connected with router. This particular incoming packet I'm sending to a PC where Wireshark has already there, F/1/1. So this is my source of traffic. This is my destination of traffic. Okay. Let me show you this, how we can do that, and again we'll discuss this. But this concept is very important. How you can take a span. So if you have issues with respect to IP phone or any multicast type of issues you have related to IGMP, sometimes if you have high CPU, if you have HSRP flap, if you have interface flap, and n number of cases, you can use this port mirroring, and you can copy the VLAN traffic or the interface traffic, and you can send it to certain destination. Okay, so let me show you that configuration step by step. So you can also simulate the same in your GNS3. In this particular GNS3, what I'm going to do now, that already I have one GNS is there. Okay, so I have this GNS3 that is running. For this, what I'm going to do, I'm going to take one router. I take one more router here, and this router, because I'm doing a span is a feature for switches. So this router, I can add one Ethernet slot. You can also add this network module 16 Ethernet switch. Okay, I can change the symbol as well. So you can think that this is something like layer 3 device. So this device I'm not using as a router, I'm going to use as a layer 3 switch. And this is router, and again I'm going to take one PC. So PC, I'm going to use my local system that at the moment I'm working on. So I have some virtual NICs inside this PC. Let me show you the NIC configuration. So I'm going to use VMware Network Adapter VMNet1. Add this. That is my local system. That is the system where my GNS3 is there. Okay. Let me connect all these interfaces. So this PC, let me change the symbol. So it is my PC. This is my local PC, Windows 7 that I am working on with virtual NIC. I'm going to connect with suppose 1/1, and other interface that is connected towards router is 1/2. Let me start both the devices, and let me open both the devices. Let me close the IOU because IOU is already there. I am focused only on the later part of this topology, that is this topology here. So PC, this PC has some IP something like 192.168.1.11, and gateway is this router interface, that is the fast Ethernet 0/0 192.168.1.1. This is the IP scheme here. Now IOU6. Let me close this IOU6. I don't want it. This is router number 2. Let me increase the font size for both the devices. I think 14 will be okay. For router number 2 and for router number 1 as well. Okay, let me recap the topology. So router number 2 is the actual router. So for router number 2, the configuration is very simple. I can go to router number 2 and I can assign a IP address 192.168.1.1 with subnet of 24. That's it. This interface. Now these interfaces I must do no shut on F1/1 and F1/2. Still, I think Imran is asking what is port mirroring. Let me complete this lab and again I will recap that. Port mirroring means you are mirroring the traffic of a port. Means you are copying. Forget about mirror, copy. What is meaning of copy? So copy means that this is original and you have some Xerox. So this original traffic is going here and we are copying this original traffic to some other destination. Okay, so you can make actually 2 copies of a same traffic and you can send in this traffic or other traffic as well. But what we are doing, what this switch will do once we enable the mirror feature inside the switch R1, that the traffic is coming in this interface, it will mirror that traffic, it will copy that traffic, it will Xerox that traffic and it will send in this interface. So we can check that traffic. It is a tool, it is a feature that you can analyze the traffic, and this feature is very important in terms of security. So if you know about the IPS, that is the intrusion prevention system, at that time IPS devices are connected with the switch and the traffic are going towards IPS, so IPS can check all the traffic and the signatures. Okay, so let me go and again I will come to that feature. First you check this lab and then we'll come back. So what I have to do next, that I'll go to router number R1. Router number R1 has 2 interfaces, first 1.1 and 1.2. So on both the interfaces, I have to no shut the interface first at least. So I can go to interface F1/1 and 2. Okay. 1/1 no shut interface F1/2 no shut. Show IP interface brief, exclude down. So my interfaces 1.1 and 1.2 are up now. Now what I'm going to do, what is my source? Source is F1/2. Sorry for that. So before starting the actual traffic, I'm going to start Wireshark. Let me start Wireshark first. So in this PC, that is 1.11, I have Wireshark installed, and here you can see now in Wireshark, be careful that which interface you are getting the traffic. So these are the active interfaces in this laptop, Wi-Fi or okay. So these are the active interfaces here. VMnet 1 I am interested of because this is connected with my switch, but you can track Wi-Fi interfaces or other virtual interfaces or LAN interfaces. So in this case, I'm going to select my interface, that is VMware Network Adapter. This one, I click on this and then I have to start. So here you can see the green color start button. Click there, and now your Wireshark will start capturing the packet. So even I am not sending any packet to this from router to the switch or from switch to the router, but still you are seeing here that he is capturing the packets. So he is capturing the packet means what? Means if we go to the topology, if we check this topology, this particular port, that is the fast Ethernet 1/1, is by default is not a port fast. So whatever BPDU informations are there, the switch is sending, I think, in both the directions. So we can verify that and then we'll start the capture. But sorry for that. Let me go to the GNS my device here, and I'll show you that here. Actually not here. Let me go to R1, that is a switch. So let me change the name, switch for a span, show a spanning tree. Because I made a router as a switch, so that's why we have such type of output. But anyways, it is okay that it is sending the BPDUs on this interface. Let me go to the Wireshark one more time, and here you can see the spanning tree packets are coming by default. If I click on any of the spanning tree packet, what are the things inside this spanning tree packet? You can see on your screen that the first is the frame. Frame is nothing but the layer 2. Then you have IEEE, that is the standard for Ethernet. Let me click on this spanning tree protocol. If I click on this spanning tree protocol, in the upcoming classes you'll come to know that in STP what are the things there. So they have something like bridge identifier. They have something like root identifier. So who is the bridge, who is the root? They know all those things. They have some BPDU flags as well. Now I'm interested on this portion. So they are sending hello packets after every 2 seconds. Their forward delay is 15 seconds, that we know. Max is, that is the, that blocking, listening, learning, and then forwarding. So 20, 15, 15. This 20, forward delay, this 15. From listening to learning is not there in this particular field, but they are sending hello packets after every 2 seconds. So these are the information you'll get from the packet capture. Actually, you'll get all the information once you enable the packet capture. So let me do the thing that why I started this Wireshark. So what I'm going to do here, I'm going to the router number 2. I'm going to router number 2 and I'm going to ping to the PC. Okay. So before I'll ping, now what I'm going to do now that I'm going to ping from router to PC. Again, I'll tell you what I am going to do here. It's very simple. What I'm going to do, I'm going to ping from here to here. If I ping, what will happen? First thing will happen is the ARP. So once ARP resolution will happen, then only they will send ICMP packets. So in ICMP, they will send ICMP echo. So echo request and ICMP echo reply. So if they will get ICMP echo and reply, both the end devices, then only they will communicate. Then only you will get this exclamatory signs for 5 times that this is successful, and they are getting the ping request and reply, and we can verify this in our capture. Once we'll do the capture, then we'll filter something inside the capture. So let me go to the router number 2 here, and let me ping. So do ping 192.168.1.11 and repeat for say 3 times or 2 times. You don't want to capture lots of packets. Router number 2. So I'm going to press enter here, and you will get all these packets. So I'm going to press enter. See ARP, then ICMP. Okay. So still they are doing the ARP. So if it is successful, one packet is successful here, you can see. I'll show you that in the filter, how you can filter it. Now I want to check the ARP. I can go to the filter menu, and there I can type ARP. You can see here we have 4 packets for ARP. So I am pinging from 1.1 to 1.11. So obviously that will be broadcast packet. You can see the destination is broadcast, because these devices, they don't know their MAC addresses. Actually switch don't know the MAC address of the devices. So if I type show MAC address table, now on interface 1.1 and 2.2 they know the MAC addresses of their interfaces. Okay. There also they know that it has sent the ICMP packet. Let me go to the you can see here ICMP echo request and reply. Okay, everything you are getting. So maybe you are thinking that I haven't configured any span here. Okay, see my span configuration is nothing. So what happened in this particular case, I haven't configured anything till here. You'll get the same result when I configure the span here. So in the normal case, what happens that because this is my virtual NIC and everything is virtual, so by default whatever traffic is coming to the switch is capturing that traffic and sending to all the interfaces actually. Now what I want to do here, I want to configure monitor session, and then I want to capture all these things. So let me go back to the switch number 1. First of all, let me go here. Let me clear these things. Everything is clear. All these are the default packets and the packets of ARP and ICMP. So how could you configure the span on your switch? This configuration is really very easy. You have to type monitor session 1. You have to give the source of the interface. So what is the source? Is interface. See, we have 2 options. Either we can give VLAN or we can give the interface. So my source is nothing but F1/2. Now you have to give the destination. The same session, what is the destination? Where you want to send this frame? I want to send on 1/1. So this is the interface where the traffic is coming, 1/2. This is the interface I am sending those traffic, 1/1. That's it. If you check show monitor session 1, it will show you that the source is 1/2 and the destination is 1/1. And we haven't used any filter, no need to use any filters. Now the same thing will happen because we have check without filter as well, but if you ping now and if you filter with ICMP, you'll get all the ICMP echo, request and reply, echo, request and reply. Now if we have any bad thing will happen here in this particular capture, see it is telling no response is found. So 1.1 is sending packet to 1.11 ping request. They are not getting any reply, so no response found. If any bad thing will happen here, you will get in the capture. Okay. So this is the configuration. Let me show you. See, now they are not pinging. So if they are not able to ping, that means something has broken inside a network, and you can see here no response found, no response found, no response. So I am sending the echo request, but I am not getting the echo reply. And if they are not able to ping, that means you can check the ARP. So what are the things you can check? Show ARP. You can check the MAC address binding. You can check the ARP binding. Show MAC address table with that. See, not on R2 actually. On go to the switch. Show ARP. Here you can check. Show MAC address table. So initially, if you check the MAC address, see, he learned the MAC address on the interfaces. Now in this case, it is not learning the MAC address of 1/1. So 1/1 is here, this. So now he is not able to learn the MAC address of this interface. So that's why he is not able to ping. That you are directly getting in the output. So I am sending the echo request. I am not getting the echo reply. So that's why the ping is not successful. So these pings are not successful. If you click here, yellow means something is wrong. Yeah, you can see no response seen. And then you have expert info, and it is telling that why they are not able to ping, because they are not getting the reply back. So these are the things you can do once you start taking captures, and once you start doing troubleshooting, you will come to know all these options, filters and everything. Now if this is one of the most important classes in the troubleshooting section, where I will show you how you can do the packet captures with respect to different platforms like switches, iOS XE, ASA Firewall and other routers like ASR routers as well. For this I'm going to cover this Cisco live PPT, that is BRKARC2011. This PPT is specifically for packet capturing and the tools related to packet captures. One by one I will discuss all the tools, because all the tools are very important. And if you do proper packet capturing, then only you will come to know that what is coming to the interface, and then you will be on the better position to determine the root cause, or what is the failure, why is the failure. So all these things. Now you can see on your screen that we have different tools related to packet capture. So one is the flexible NetFlow. Apart from that, we have some embedded packet capture tools. Embedded packet capture tools, something like embedded Wireshark that we are using in iOS XE. In the Catalyst switch or switch platform, we have either SPAN, RSPAN or ERSPAN. Apart from that, we have this option of EtherAnalyzer in Nexus and the NetDR in Catalyst 6500. You can use different type of ACL to map while you are doing the packet captures. If you want to do some ASIC level packet capturing, you can use ELAM with respect to Catalyst switch and with respect to Nexus platform. And finally, you can summarize all these things. These are the acronyms for all these things, like for RACL, PACL, NetDR, COP, ELAM, VSS. So we can take a reference from these acronyms. What I'm going to do today, that first of all, I will show you one example, and then I'm going to do packet capture with respect to iOS. In this particular example, what I'm going to show you here in this PPT, that suppose, take an example, suppose if you have high CPU with respect to NetFlow, then how could you identify that, oh, this IP is the source and this IP is the destination, and because of this IP address, my NetFlow is that much high. Before understanding how NetFlow works, you have this PPT where you can understand that what are the pieces inside the NetFlow. Inside the NetFlow, we have actually 3 pieces. So piece number 1 is the record. That first of all, you have to determine the record. So whenever you are configuring the NetFlow on iOS or iOS XE, these are steps you have to follow. Inside the record, you have different you can say that different variables or different parameters. So you have parameter like source address, destination address, port number, destination port number. Apart from that, you have application. So you have actually 7 parameters. Those parameters are mandatory, means you have to give those parameters, and apart from that, you have collect option. Collect option are optionals things. So if you want to collect bytes, packets, you want to collect the timestamps, etc. So once you define the flow record, after that you have to define the exporter. So here you can see. Now in this case, I have 2 exporters, exporter 1, exporter 2, means this flow I am exporting in 2 different exporters or via 2 different exporters. So here, suppose this is sample exporter 1, where my destination is this VRF, source is this loopback, and my other exporter has different destination in the same VRF, that is the management, with the same port number. So I have one sample record. So this is my record, this is my exporter 1, this is my exporter 2. Finally, you need one global program, so you have to glue these parameters inside one program. That glue is nothing but the flow monitor. So inside flow monitor, first of all, I am calling the record, that is the sample flow, and then I am calling my exporters. So once you are done with the step number 1, step number 2, step number 3, the 4th step is to apply this policy. So apply this NetFlow policy. You can see here step number 1, 2, 3, and this is the 4th step where you are applying. So you can apply on gig interface 111, 10 gig interface 2222 in the input and output direction. This is the overall example, or this is one example about NetFlow, that how you can apply. So if you have something missing, or if you have any trouble to understand how you can configure NetFlow, you can use this example. Okay. Now, in this particular example, because I am doing some capturing with respect to suppose high CPU, so I am taking one example related to high CPU. How could I capture this NetFlow packet inside? Suppose in this case I am using 2T. So this example is with respect to 2T. Whenever you have high CPU, what command you check? Show process CPU sorted and then exclude 00. In this case, if you are getting high CPU due to IP input, you can see here high CPU due to IP input. That means that your IP traffic, means your flow through traffic is much. Again, there are 2 types of traffic. One is the process switched and one is the flow through traffic. Now in this case, actually you have 2 counters, so 65 and 8. If you subtract 65 minus 8, you will get, actually this is your flow through traffic, and something like 55 or 57 will be your CPU traffic. So in this case, I have to capture traffic with respect to CPU, with respect to control plane. So what you can do here, you can check this parameter. This is again very important parameter. This 65 is overall, and the second counter is suppose 8 in this case is the flow through traffic, means the traffic is flowing through that device. So this is flow through traffic. If you subtract 65 minus 8, you will get something 57 or something. Means now you have two things. 8 is flow through and 57 is CPU. Okay, so flow through traffic is 8 and 57 is the CPU generated traffic. For that you have to capture your control plane. Now in this example we can capture inside the control plane. How? So first of all I will create the record. You can give any name, whatever XYZ. What are the things you are capturing in the control plane? IPv4 protocol, IPv4 source address, destination address, source port, destination port, and collect interface input and packets. Second is what you have to do. You have to create the monitor. So you can just refer the first slide. So what are the things you are doing? Step 1, flow record, flow exporter, and then the monitor. Monitor is actually the third step. So there is no need to create the monitor. So flow record, flow monitor, and then the control plane. Now this is one of these corner case that you will get. You have to do this capturing with respect to NetFlow. So record, monitor, and inside this monitor you are calling the record. Now this particular policy, monitor policy, we are applying here with respect to control plane. So first, second, you can counter this as a first and second. This is the third step. This is the fourth step. Once you have done that, now you can check. So if you check inside your control plane, that show flow monitor, this is the flow name, cache, short counter packet, you will get who is the source, who is the destination, means who is generating this flow through traffic, and what is the destination it is going. Once the flow is identified, further action could be blocking the flow with an access list or a rate limit inside the control plane. So we'll come to know how we can do the rate limit, but what you can do in the meanwhile, that you can block this particular traffic with certain port number. So with specifically with this port number, that is the 63, you can block this traffic. So your CPU spike will go down. This is one example with respect to IP input in soup-to-nuts. So if you have IP input process that is a spiking high, what you can do, you can create a flow record, you can implement inside control plane, and you can check with the help of this command. Okay. So this is one use of NetFlow, plus how you can do capture with respect to NetFlow. Please go through this these 3-4 slides. Now today the next topic that I'm going to cover is the packet capture inside iOS. So if you have iOS, how you can do the packet capturing. iOS means you are running something like iOS based platform, okay, not iOS XE based platform. So for that I'll show you in this particular, yeah. So in your screen you can see here, this is the document I already uploaded in the Google Drive. This is the table of content, and actually this is the summary that I have done from that Cisco Live, and this summary is a bit easy to understand because you will get all the commands here within 300 lines. All of the commands related to all the platform. So you can see on your screen that platform related to iOS, iOS XE, ASR 1000, 6500, 6800, 4500, 4900, and Nexus 7K, and the switch port is Analyzer and the ASA Firewall. So today I'm going to cover this EPC, embedded packet capture inside the iOS. For that, what you have to do, and these are the steps that will follow. That for this particular case, I'm going to show you inside the lab. So I have one lab where I can show you this thing. And one by one means in the subsequent classes, I will cover all the other platforms, all the other iOS as well. Here I have my GNS3. You can also simulate inside GNS3. I'm going to take one router, iOS based router. Suppose in this case I am using 7200. This router I'm going to connect with local PC. That local PC is my laptop itself. In my laptop I am using some VMware. You can see here that virtual box only. I can add this. So this is my NIC, virtual NIC. I'm going to connect this router with my virtual NIC. For router as well, I need some interface. So what I can do right click on router number 1 and I can choose one interface. So suppose I am choosing slot number 2FE. Okay, now I can connect this router with this PC or the virtual interface. This PC I can change the symbol so it will look like a PC. Okay, this is my connection. Now what I'm going to do, I'm going to start the router engine and it will become green. Once it will become green, I will configure that router with IP address 192.168.1.1. So here my IP address is something 192.168.1.1/24, and this PC has IP 192.168.1.11. In this PC itself, I will show you that I can actually this PC where I am taking this capture, I'm going to take the captures. This PC is TFTP server as well. So this PC I have installed Wireshark, and inside this PC I have TFTP as well. I'll show you that I have TFTP server in this PC, I have Wireshark in this PC, I have virtual NIC in this PC. So in this router I am going to configure some packet capturing things, and because Wireshark I have installed here, so what I will do, once I will enable the packet captures on this router, I will export that file to the TFTP server and I will open that TFTP file with the help of my Wireshark. So that is the overall idea here to do. Let me go to the router, let me configure that router. So I start the router. Let me increase the font size so it will be visible for you. Bold 14. Yeah. I'm going to assign one IP address on this particular router, and the IP address, you know, that 192.168.1.1. So once this router will come back online, I will do that, and then I will do the configuration related to the captures. Now while this router is coming up, what type of captures you have? So remember, you can take two types of capture. One is flow through traffic, means assume that this router is a transit device and the traffic is going via this router. And second case, you can take captures on this router, means you are pinging from somewhere to this router and you are taking capture. So that will be CPU capture. So either you have something called hardware switch traffic, or you can have some CEF traffic or some process switch traffic. So likewise, you can have the options as well. So the router is now ready to configure. Let me go to the router. Let me assign one IP address. Interface fast Ethernet. What is the interface? Let me check that. Interface is 0/0. IP address is 192.168.1.1. If I want, I can check the connectivity as well, but I'm not going to check the connectivity. I'm going to configure the monitoring in this device. So if you want to configure the monitoring, the steps are monitor and you have to do the capture. You can limit the buffer size. Now if I type question mark here, you have two options. What is the monitoring capture point? You can see here, if after monitor you can see monitor capture, monitor traffic, monitor process. I'm focused on capture. So once you capture, you can specify the buffer, that is the size of the capture, and the point from which point you are going to start the capture. So first of all, I am taking the option of buffer. Suppose the buffer name is something like rat buffer, and then it will ask for the size. So size I can give, you can see the lower limit and the upper limit. Default is 1024. So suppose I will take 2048, and then it will ask for what is the max size. So max size from here up to where you want to go. So I can go, and it's very important to understand here the minimum size is 1024 kilobits, and these are in the bytes. Okay, so these are in the kilobytes and these are in the bytes. So the maximum size I'm going to use here is suppose 4096, something like that. Now it is asking your buffer is what, circular or linear. Just forget that. Then monitor capture, this time I will use point, and I want to capture, I will show you both the option. So if I'm using IP, and then if I'm typing question mark, you have two options. It's very important to understand that which type of traffic you are capturing. Either this is CEF, Cisco Express Forwarding, that is purely hardware switch traffic, or is it process switched? Process switched is something like software switched traffic. So this is a program inside the CPU, or this traffic is programmed inside the hardware. Okay, both are two things. When a packet is coming, it is going via software switch. Software switch means it will increase the CPU cycle. So first packet is obviously going via software, but that packet is means whatever the headers and whatever the source and destination, those are programmed under the hardware, that is programmed under the CEF. So next time if the packet will go, it is taking the path of the Cisco express forwarding or the hardware. So next time it will be CEF switched, not the process switched. So we have two type of switching, CEF switching and process switching. Now the thing is that suppose this is my, this is my router. Suppose if you are pinging to the router, that means you are pinging to this router, that is your destination. That means that will be software switched or process switched, because you're pinging to the device. So that's why if you're pinging to the device, that is not a legitimate way to test the device. If you ping the device, obviously that will be the CPU processed, or that will be the process switched. Okay, so please do not test anything to ping a certain device. You can ping to a router or switch just for the connectivity, not for the throughput or the overall bandwidth testing. You can't do like that. Okay, first thing. Second thing, that if in your ACL, if you will use a keyword like log, that will be software switched. Okay, so these are the very important things to understand. Which type of traffic is software switched, which type of traffic is safe switched. Okay, in this case, because I'm going to ping to the router, so I can use process switched because I don't have other device in this topology. But if I will use some other device, I can ping, I can use the safe option. So in this option, I'm going to use process switch, but you have to identify which type of capture you are taking. Is that traffic is safe or is that traffic is process switched? You can give any name. Suppose I will give name something like RATCAP. Okay, here it is asking about, I can give both in and out, no worries. So what I have done so far, show run section monitor, you will get the output here, you will not get the output here. Okay, so what I have done so far, if I type show history, I'll show you. I configured two things. One is RAT buffer, that is showing that this much of packet I am capturing, and in the second line you can see that I am capturing towards the CPU. So this is not the flow through traffic. If you want to capture flow through, you have to use the safe keyword. And then the other two lines are completed. The third line is that you have to map the buffer with the point. That will be the final statement. So monitor capture point, and you have to associate capture point. So what is my capture? My capture is this and question mark. What is your capture buffer? So first is the capture point. So my capture point is, actually this one is my capture point. You can see capture point. So first is, it is asking for, do not want to confuse it. So first it is asking about the capture point. So capture point is this. And second, it is asking about the capture buffer. So capture buffer is this. Means we are associating the both the things. So once the association is done, then the final command is to monitor capture, and you have to start this. So point start, and you have option. So what you want to start, you can give the capture point name. So capture point name we have RATCAP, or you can use all. So once you start this capturing, it is telling the RATCAP has been enabled. Before I will send any interesting traffic, let us recap this thing. So if I recap this thing, I have this document here. Let me open that document. This is very, this 5-step process. You can see 1, 2, 3, 4, 5. What you have to do, this is the mandatory statement. So you have to define the buffer. So monitor capture buffer, whatever name you want. Suppose in this case, this is the size. Then the second point is the identification phase, that which type of traffic you want. You want safe type of traffic, that is the hardware switch traffic, or you want the software switch traffic, that is the process switch. So suppose in my example, I use process switch traffic, but if you want safe switch traffic, you can use it. Now the third option, that you have to associate the buffer. So capture name, that is your capture point. So you have to associate capture point with capture buffer. That is the third, capture point, capture buffer. Fourth is to start your process. And obviously fifth one is to stop the process. Okay. So I have started the process, but I am not sending any traffic. Let me send some traffic. So let me go to command prompt and I can ping to 192.168, that is the router IP, and -T. So I am pinging to the router. Because my capture buffer is on, I can check show monitor capture buffer all because I don't know the name. So it is telling that rat buffer is the buffer, maximum size is this, packets 58, 91, 103, buffer size is this much is the byte size, the status is active, these are the configuration for the buffer, and the packets are increasing here. Now if I check show monitor capture point all, so for the name is the rat buffer for that point, switch path is IPv4 process, status is active, and this is the configuration. Okay, so once you are done with all these capturing, means they are start capturing the configuration or the packet, then the final step is to send those packet inside the TFTP server for analyzing. So before that I have to stop this capture. So what I can do, I can use monitor capture point, and then you have the option of a stop all. Now it has been stopped. Now you can see this syslog message, buffer cap 6 disable, packet capture point disabled. Now you have to send this inside the TFTP server. So I have TFTP server here. I can open that TFTP server as the administrator. Cannot create socket. Okay. This is my TFTP server at this address. Let me send my packet, that is the rat cap, to the TFTP, and the command is monitor capture buffer. You can see here in the step number 6, that is the last command. So monitor capture buffer name export. What is my buffer name? So I can check my buffer name. My buffer name is rat buffer. So monitor capture buffer rat buffer export TFTP, and my TFTP server is 192.168.1.11. Now I can give any logical name. So name will be something like my dump file name. My dump file name is what? It's something like ratcap or something. Ratcap. So I can use this name with the .pcap. Pcap is nothing but the extension for Wireshark, and then enter. I can check here if file will transfer. It will show successful here. If it is not, then it will show unsuccessful. We can see that file is not going to this location. No problem. I'll check the command one more time. Monitor capture buffer name export. That is 100% correct. Let me check my TFTP server. So copy, suppose run to TFTP. Is my TFTP is working or not? First check. And suppose running.txt. We can check TFTP server parallelly. Yes. So if file will transfer, no, the file is not transferring to the TFTP server. So what I can do, let me close this TFTP server. Run as administrator. You need this administrator privilege. Otherwise, this will not work. Okay. Okay. Let me check one more time. So it is not exporting. No problem. We'll troubleshoot this for a minute because I am able to reach to the TFTP server, but my TFTP server is not responding. It is not taking actually the right action. So I can do one thing. I can change my directory. Maybe in the C drive it is not writing, or we can do one other thing here. Okay, so give me 2 minutes. I'll do the troubleshoot of this TFTP server. Now my TFTP server is working. You can you have seen that how much troubleshooting I have to done. Okay, now the final step is to send your file to the TFTP server. For that you can use monitor, and before doing that, let me check the files. That is the capture file, capture buffer file. Show monitor and then capture and then buffer all, and then you have to give the parameters as well. This is my buffer name. Okay, now I can do monitor capture buffer. I want to export this. The name of the buffer is capture buffer, something capture name. Then export to TFTP //192.168.1.11, and the name I can give. Now be very careful here. What is your capture name? So buffer name is actually not this. Your buffer name is something like your buffer name, because finally what you have done, this step is like association between two objects. So finally what I have done, this capture name I have merged with the buffer name or associate with the buffer name. So here I need buffer name instead of capture name. Export TFTP 192.168.1.11. Then you need the pcap file. So you can give this capture name .pcap. You can give any name. Pcap cannot export content to the active buffer. So it is telling that this buffer is not active because maybe I haven't started the capturing. So ping is going on. Let me check monitor. That is the fourth step. Capture point start all. So once you start this, it will show you that it is started or not. And then you can, once it is started, you can stop as well. Capture name is disabled now. See, file is transferring here. This much file is going inside the TFTP server. This is successful. Now what I can go do next, that I can go to my directory, explore it. I can go inside my TFTP server where I have this capture file name in form of pcap, and I can check my captures. So you can see here all these captures I have done. I have exported from the iOS, and all the ping packets you can see here, ping packets echo require. So whatever traffic is going through, in this case I use the ping or the ICMP, but you can use your network like this. So once you have this Wireshark, you can ICMP, you can filter through this how many packets with what, and you can verify. So this is about how you can do the iOS capture. Now if you have any question, I'm going to take session on the packet capture part 2, and in this particular session I'm going to discuss other packet capturing tools with other devices. You can see here at least we have these 3 tools. So in Cisco iOS based router like 800, 1800, 7200, ASR 1000, we have something called embedded packet capture that we have seen in the last class, that we took captures inside 7200 and then we'll send that capture to the TFTP server. Further, to analyze that capture, we use Wireshark. Likewise, you can use the same methodology inside 800, 1800 or maybe 2800, 2900. In ASR, it is bit easy than the 720 and other platform. So today I will show you how you can do the capturing inside ASR. We have done this thing as well, that is how we can take a span. Span is very easy to take. So let me show you. I have one switch, I think, with me. And on that particular switch, let me show you the captures. So do I have screen here? Okay. So I'll show you that inside the switch. And you can see here, let me cancel this, and I have this switch here. You are able to see my screen, correct? So this is one of the switch. Let me show you what version is this running. This switch is something IOU based model where it is running Advanced Enterprise 15.1a. So whatever versions we have inside, whatever features we have inside 15.1 with respect to layer 2, you can execute all those control things inside this. Let me check that I have this option of monitor session or not. Monitor session is not available in this particular train, but I can do one thing. I can do the last class thing that in the previous session we have discussed about iOS based capture. For iOS based capture, you can see you have these 5 steps. So step number 4 and 5 are very easy. That is step number 4, actually 4, you can see that you have to start the capture, and this start of capture is true for actually all the captures. So you have to start the capture, you have to stop the capture. That means you have these 3 steps where you determine what is the buffer size, what is the point of capture, what is the name of capture, what is the type of capture. So what are the things you define in all types of captures? That obviously you will start the capture, you will stop the capture, but you will define the buffer size of a capture. What is the point from where you are starting the capture, so the starting point of the capture, and what type of traffic you are capturing. Is it a safe or hardware switched, or is it software switched? So once you define all these 3 parameters, then you have to start the capture. So you can start and then you can stop the capture. So once you start the capture, once you stop the capture, after that you can export that file to the external server. So suppose in this case, I'm exporting to TFTP server. Here you can see, export that buffer to the TFTP server as a .pcap. That is the extension for Wireshark. The same thing I can show you here one more time, and then we'll proceed. So how you can define the capture, let me scroll down this a little bit so you and I can see the commands, and obviously you can save these commands. So once you understand these commands, you can save somewhere, so next time you don't need to you don't need to memorize this command. So I'm on step number 1 where I am giving the name of the buffer, something buffer, suppose buff, and you can determine the size. Max size is suppose 4092, same as in the above. Then this is the point where you are starting the capture. So the capture point you can give IP based. Now once I am giving IP based capture, I have option, either I can use hardware switched or software switched. Suppose I am using software switched traffic, then you have to give the name. I can give, suppose, cap, and in the ingress and the egress direction, both in and out. So 2 steps are done. Now what you have to do in the third step, that you have to map the first, that is the buffer, to the second, that is the cap. So third one is very easy again. Capture point, you have to associate the cap with the buffer. Enter. And once you've done all these things, then you have to start the capture. So you can do monitor, capture, point, start, and you can give the name. So if you type all here, you'll come to know that it is starting. So if it will start the engine, it will show that the cap has been started. You will get one syslog message. Yesterday we got that syslog message, and once it will capture those packets, then you can monitor, capture, point, stop, all. That's it. For verification, show monitor, capture, buffer, all, and then you have to give parameters. So these two lines related to buffer, and if you want to check the show monitor, capture, point, this is one point with respect to capture. Okay, so this way you can check the iOS based things, and once you check that, after that you can export this to the TFTP server as a PCAP file, and then you can verify that. This was the capturing trick inside iOS related to 800, 1800, 2800, 7200. Now if you want to capture inside ASR capturing is bit easier, and yeah, it's bit easier than the iOS. So I'll show you that ASR capture as well, but first let me go back to the PPT, and in this PPT we can discuss here. So what types of captures we have? We have EPC, that is the embedded packet capture. So the example of EPC that we have seen, that was related to embedded packet capture. You can use all these things. Even I am going to take example for ASR as well. Apart from that, you have mini protocol analyzer. So this mini protocol analyzer I will show you with respect to Catalyst 6500 or Catalyst or Cisco 7600. Both the platform are the same, or ME 6500. And then you have the Wireshark. Actually, you can use this Wireshark as an external capturing tool or internal capturing tool. So inside embedded Wireshark, you have inside 4500 plus 38500. Sorry, 0. So inside 4500 and 3850, we can use the embedded Wireshark as well. But these two things today I'm going to cover up. Let me go to the next slide of this. These are some comments that you can use actually ACL, and you can filter that. I'll show you with the example as well. Obviously on all the switch platform you can take a span or R span or ER span as well. That is also true. Now this example is with respect to ASR. So the bottom example that we have just covered. So we covered that buffer mybuff, then the point, I use something like cap, then the association of buffer with the point, then you have to start, then you have to stop, and then you have to export. So these we have already know. Now let me cover this, that is the ASR. So in the ASR platform, how could you capture? Now if you check the ASR platform with respect to this iOS, both are 70% similar. So what are the commands? I have the commands in my notepad. Let me show you the notepad commands. And the notes is already shared inside the Google Drive. Okay, so ASR, please come down. This is different way to capture inside ASR. Okay, let me show you here first in the PPT. So how you can do, the first two keywords are same, monitor capture. Third is also same, that you have to use mycap, then buffer. You can define the number of packets. You can define the buffer size as like 10 MB. Now, where you are capturing, that is also a good point. So we are capturing somewhere. Okay, let me. Okay, you can see here that this way you can do the capturing inside iOS. Now in the ASR router, how could you do the capturing? First two keywords are same, and you can use buffer circular packets. So suppose if you want to capture 10,000 packets, buffer size is something 10 MB. Now I am capturing packet on this interface, that is gig 001. You can use this in the inward direction, that is the in. You can use access list here in this case. So on that access list, what you can do, you can define what is the source, what is the destination. You can use IP. I will show you in the next slide. You can start the capture, you can stop the capture, and you can export to the boot flash. And if you want, you can check via the command line. Otherwise, you can export that file to the TFTP server. And inside the TFTP server, you can open that file with help of Wireshark, and you can check that. So this is again very similar to how you are capturing for iOS, even though it is very structured. You can see the structure. So what you have to do, you have to only follow the step number 1, 2, 3, and 4. This 5 and 6 are common, and this 7 is common here. So 3 steps are common. You have to define the packets, size of the buffer, in which direction you're taking the capture, and where you are locating your capture. Let me go to the next slide, and how you could verify those things. So the verification is again very easy. Show monitor capture is common. After that, your capture file name is cap. You can check like parameter. You can check like buffer. Now, after buffer, if you type question mark, you have two options, detailed and dump. If you type, suppose brief, detail, and dump, if you type brief, it will show you what is the source of the address, what is the destination of the address, what is the protocol type. But if you do dump, it will tell you the hex format or the upper level protocol or the upper level format. This is the dump file. This dump file actually you can decode with the help of Wireshark. In the detail as well, you have both the mixture of the brief and the dump. I will come to this Catalyst platform and the Nexus platform in the upcoming classes. But still, if you want to do capturing in the Catalyst, if you want to span, you can see here monitor session 1 type capture. You can define the source, and then you can do all these things. I'll come back on this 6500. Just exclude this 6500. We'll come after some time on this. So I am focusing on ASR router. Again, I will come on this as well. The 4500 platform and 3850 platform. Both are using embedded Wireshark. Either you can use embedded Wireshark or you can use a span feature, but I'll come back on that. At the moment I am focusing on ASR. So how we can take captures inside ASR, and then I have to explain this real-time scenario. So in case of ASR, how you are capturing the packet, the steps are easy to follow. What are the steps? So step number 1, 2, 3, 4, 5, 6, 7. First step is to how many packets you are capturing, what is the size of your capture, in which direction, on which interface you are capturing, what is your source and interested destination, or what is your interested traffic. It is defined under ACL. You have to start, you have to stop, and you have to export the file. Okay. Now this is the real world example of what is the use of packet capture, what you can do. Now in this particular case, client, that is PC1, is complaining that while I am pinging to PCB, I have packet loss. So you may have one site that is connected with ISP, you may have other site. So suppose you have site A and you have site B, and when you are pinging from one PC of site A to the other PC of site B, you have issues. Or you are connected via LAN device, and when you are pinging from one PC to other PC, generally you will not face this issue in the LAN, but if you have any packet drops, what you can do, and maybe your other PC is multiple switch away, so it is 4-5 switch away. PC A is connected with local switch, PC B is connected with some 5 switch away with some other local switch. So such type of scenario, how you could capture the packet. This case is specific with the ASR. So my PCs are connected with ASR router, and while I'm pinging from PC A, the IP of PC A is something 10.5, the IP of PC B is something 30.5. On PC A, I'm pinging 30.5, 5 packets with the length of 100. With the length of 100, there is no drop. You can see I'm sending 5 packets, I'm getting echo reply for 5 packets. So this is 100% success, no loss. But if I'm increasing the length of packet, that is if I'm using length as a 1000, and if I'm sending 5 packets, at that time you can see that packet number 1 and 2 are successful. Then I have timeout, and then successful means out of 5 packets, 3 are successful and 2 are dropped. Now in this particular case, you can see where the packet will drop on this interface, on the, say, suppose ingress of this ASR, or egress of this ASR, or ingress of this ASR, or egress of this ASR. Means you have 4 points to capture. Now you can exclude the first point, because why you can exclude the first point? Because if in this direction, that is the egressing to ASR 1, if you have 5 packets, that means your 5 packets are reaching up to here. Okay. Likewise, you can check that. Let me show you the next slide where we can have the capture. So what is the source and what is the destination? It is very important whenever you are doing the troubleshooting with respect to switch, with respect to router, with respect to ASA firewall, you must know the source, you must know the destination. Once you have the source, once you have the destination, once you have the topology diagram, that is the second thing. Third thing, you have to trace the path. So you have to trace the path, that how the packet is going from A to B. Either it is a hardware switch or it is a software switch. Means is it a safe switched, or is it a process switched, or something like that. So you have to identify these 3 things. Now in this particular case, 10.5 is my source, 30.5 is my destination. So you can see here in the diagram, I am capturing here and I am capturing here. The same thing, I have my access list. Source is 10.5, destination is 30.5, again in the reverse direction. that is for echo reply. So you know ICMP how it works. Echo request and the reply is echo reply. So on the egress interface of this, I have this access list. The commands are very simple. That initial third command, then this one is the fourth. Gig 0/2, both access list this start and stop. Likewise, here source destination on gig 002 start and stop. So on the router 1 gig 002, router 2 gig 002. Okay, so I am capturing on these 2 points. Now, if I see the captures, what I will find. So on this interface, the captures are something like that. If you check show monitor capture cap1 buffer detail include ICMP, pipe include ICMP hash, you'll get that, okay, I am sending 5 packet. So this is packet number 1, echo request, this is reply, good. This is echo request, this is echo reply, good. This is packet number 1, this is packet number 2. Echo request means for consecutive 2 packets. So packet number 3 and 4, I don't have any reply. Then the last one, echo request, echo reply. This is the fake packet. Means here also I am seeing that 2 packets are dropped here. So packet number 3 and 4 are dropping here. If I check on this interface, echo request, echo reply, echo request, echo reply, echo request, echo request, echo request, echo reply, means here also packet number 3 and 4 don't have echo reply, means they are dropped. What does it mean? It means that these 2 interfaces are not dropping the packet. Okay, I'll conclude that, but still on this interface also I have 2 packet loss. On this interface also I have 2 packet loss. Then I will capture on this interface. So let me go to the next interface. I'm capturing packet here. How I am capturing? Again, I am creating the cap on the gig 001 interface with this access list. This access list is nothing but, you know, that access list, source, destination, destination, source, start and stop. So I am checking there. So you can see here that echo request, echo reply, echo request, echo reply, and then echo request, echo reply. So EPC capture on gig 001 confirms that only 3 echo request and echo reply. So what this interface is telling, that here I have 3 ping. So here it is not showing out of 5, 2 are dropped. Here it is showing 3 packets are coming, 3 packets are successful. In this interface it is telling that 3, say out of 5 packets 2 are successful, out of 5 packets 2 are successful. Okay, so what does it mean? It means that whenever packet is coming to this interface, this is dropping, means we have issue with ASR number 2. Okay, because while the packet is leaving this interface, 3 packet is going out, we are getting the 3 reply. The same way you can figure out in the ASA firewall as well. So let me conclude this. 5 packet is coming, 5 packet to drop, 5 packet to drop up to this interface. 3 packet is coming, 3 packet is successful. That means here is no drop. That means I have drop on this interface. Okay? So this way you can take path captures, point by point you can capture, and you can come to know that which particular device is faulty, on which particular device it is dropping the packet. So once you identify, oh, this device is dropping the packet, then you will do the needful, then you will take the needful action. Okay. This is the third in the packet capture, and this is one of the important class in this packet capture series. In this particular class, what I'm going to discuss, you can see on your screen that I have couple of devices. Now, if you know ASA Firewall, that is well and good. If you don't know, uh, please visit this video, please watch this video 2-3 times, then you'll come to know. At the moment, all these routers switches in this particular topology has blank configuration. So I'm going to build the configuration for ASA firewall. So suppose this is my inside zone, this is my outside zone. The outside zone has a or should have a lower security level, and the inside should have a higher security level. So by default, the ASA firewall will permit the traffic from the high security zone to the low security zone, and if we have connection in the state table, then the return traffic is permitted. Now, this router, you can see here, these router, this is the internal router, this is the external router, and this is my switch here. So this is one of the router. I made this router as a switch where I'm going to take a span capture. In this particular device, that is router 1, I will take iOS capture. I'm going to take iOS capture. In this particular machine, I have TFTP server, so I will send that capture to the TFTP server. I can span this particular interface, say suppose F1/2, and this span, that is the port mirroring, again I will send to this PC. Third capture, so this is capture number 1, this is capture number 2. Third capture I'm going to take in this direction from the ASA firewall, means when the traffic will flow with this source address and this destination address, something like 2.1. So I will make one access control list with the source of 1.1 with a destination of 2.1, and inside the ASA firewall I'm going to take capture. So these are the steps involved today for the captures for the lab. So let me show you the configuration for all these devices. What I'm going to do, entire all the devices I'm going to run OSPF in area 0. So I must have reachability end to end. So everything will ping everything. And this is the IP scheme I'm going to use here. So this is .1, this interface is 2.12, this interface is 1.12, like that. This is .1, and on all the devices you can see that I have loopbacks as well. So even I can create access list with respect to loopback, and I can use source and destination and source as a loopback interface as well. So let me walk through you all the configuration for all the devices. I already logged on all the devices. This is my empty putty, and I can see what are the interfaces I have. So let me check the interfaces. So F00, here also you have F00. The inside interface is E0, this is E1 actually, and for this switch the interfaces are obviously, this interface means the connection from the switch to the ASA firewall. I'll make this as a trunk interface. Router to switch, I will make this as a trunk interface, and this F1/3 I can make it as a I can make this as a access VLAN or something like that, but let it be like this. After some point of time I will create some VLAN on router number 3 or the switch number 3, and will configure according to that. So let me first configure R1, R2, R1, R2, and the ASA firewall, and then I will configure the trunks. What I am telling here, that this connection is trunk. So trunk means that you are passing all the VLANs. This is trunk. Trunk means whatever tagged information with respect to VLANs you are allowing on these interfaces, and encapsulation obviously will use .1Q. Okay, so let me show you the configuration. Let me build the configuration for all the devices, and one by one I will show you everything. So let me go to router number 1 and assign IP addresses. For router number 1, I'm going to use something 192.168.1.1. Loopback is something 11111. Do show IP interface brief. You can check the unassigned. And here what I'm going to do, I'm going to start this OSPF process in this router with the network, some default OSPF network. Otherwise I have to give the actual subnet mask, actual network and actual wildcard bit, but I'm using everything here so I can save my time. Do show run because this is iOS based router, so you have to use this command. So I'm very good with the configuration of R1. Now I'm going to configure R2, that is the other side, that is the outside router. Here also I have the interface fast Ethernet 0/0 with the network of 2.0, and I have loopback something 222. Here also I can use router OSPF command, and I'm good with the configuration of interfaces and the configuration of OSPF. Okay. Now third thing, what I'm going to do, I'm going to enable the interfaces for the router 3 or the switch 3. So I have to enable the interfaces. So this interface should be trunk. This interface should be trunk. F1/3. I will convert this as an access after some time. So let me go to the switch number 3 or router number 3 and make these interfaces as a trunks. That is F1/1, 1/2. This is my switch. Interface range F1/1 to 2. Switch port trunk encapsulation .1q. Switch port mode is trunk, no shut, and the other interface 1/3 for the moment I will do no shut. So if you check the configuration for 1/1 or 1/2, you'll find that they are the trunk interfaces, and one side is going towards router and the other side is going towards the ASA firewall. If I exclude down, you can see these three interfaces are up, and these are the member interfaces for VLAN 1. Okay. Now the last configuration is the configuration of ASA firewall. So ASA firewall, this is my ASA firewall. I have two interfaces on ASA firewall. So 0/0 has name inside. So once you define the name as an inside, what you will find that it will take the security label of 100. So inside I don't want, I actually want inside. So name is inside, and if you want to assign the security label, you can assign security label as 100. Unset the port, and the IP address is 10.1. something. Not 10 actually, 192.168.1.12. So according to the diagram, you can check that. This is 1.12 E0/0 with a subnet mask of /24. Because this is no shut, you can ping from ASA firewall to the internal router, that is 192.168.1.1, and we are able to reach. So in this inside zone, we have connectivity. Likewise, I can configure the other interface, that is the outside zone interface. So name if is outside. By default, it took a label of 0. No shut. IP address is something 10, not 10 actually, 192.168.2.12, and the subnet mask is 24. If I verify, we don't need this do command. Simply if you ping from this mode, it will ping 2.1 is the router IP from the outside. That is 100% correct now. So I have the IP on the interfaces. Now what I can do here, I can enable router OSPF. Now in ASA Firewall, the OSPF command is little bit different than the normal iOS or the normal switches. Here what you have to do, that obviously you have to use the network command. So you can use network command. All the networks are belonging to 10 series, and instead of wildcard bit you have to give subnet mask. So in normal iOS, what you are doing whenever you are advertising a network, this is in form of wildcard bit, but inside ASA Firewall this is in form of subnet mask. So subnet mask, I am using something /8 within area 0, and that's perfect. Now we can check routes related to OSPF here. So once they will converge, they will show you the route. So at the moment they haven't converged, but once they will converge, you will get the routes. So you will get the routes inside the ASA Firewall routing engine, that is the OSPF engine. That doesn't mean that you are able to ping from one location to other location, because by default what ASA Firewall will do, it will block the incoming packets here. So what you have to do on the outside, say this is inside interface or zone, this is outside interface or zone. So what I'm going to do, I'm going to create one policy here in this interface in the outward direction, that everything is permitted. So let me do that. Actually on this interface I'm going to create two policies. One is going out, so going out is always permitted. Coming in, I'm going to allow. So in and out, I'm going to create one access list and allowing inside and outside traffic on the ASA Firewall. Before that, you can check here that still they haven't got the OSPF information. So let me verify with respect to OSPF that why they are not getting the OSPF information. And if I check show run OSPF something, show run, let me check the OSPF configuration here. So the router ID is something, oh see, I haven't advertised the correct network. So let me remove OSPF. I advertise with respect to 10. How you can do that? Simply no router OSPF, and then router OSPF 1. Router ID I can use something 192, suppose 1.1.1, something like that. You can use any router ID. Network I can use 192.0.0.0.255.0.0.0 area 0. Show route. We'll wait for some time. So it will converge. Once it will converge, we'll get the loopback information related to all the show SPF neighbor. You can check the neighbor information. So they are forming the DRBDR adjacency. That means you will get the routes as well. So you can see from internal router I am getting the routes, from external router I am getting the routes. But if you ping from the internal router to the external, say if I ping to 2222, that is the loopback here with the source of 111, that is my loopback, I'm not able to ping, because in the ASA firewall the return traffic is dropping by default. So what I'm going to do here, that I will repeat this for 1000 times, start the ping, and I'm going to create one default policy to allow everything. So for that, access list, and you can give name of access list. Say suppose access list all permit IP any, and then you have to apply this access list inside access group all inbound to the outside, and access group all outbound to the interface outside. That's it. Now if you check on R1, you are getting the pings because now I am permitting everything. So my basic lab is very much good here. It is working perfectly fine. Let me show you the other parameter as well. So this PC, can I ping from this PC to this router? Because by default this is in VLAN 1. So let me, this PC is my local PC from where I am taking this class. So let me ping to the router. This is the gateway of the router 192.168.1.1. At the moment I am not able to ping to this router, so I have to check what is the IP on my NIC card. Let me check the IP address on my NIC. This is my card, and what is the IP on that card? 56.1. That is out of range. So let me do one thing. Let me go to the IPv4 properties. Let me change the IP address. This process may be a bit slow. So what I'm going to do, I'm going to assign the IP address 192.168.1.11 on the NIC, and you can see that things are very slow, so I can pause. Once I pause, yeah, pop up. Go here, click here, assign IP 1.something11, and then give the gateway. That gateway is the router gateway address 1. Okay, and let me verify. So start all the engines, go here, ping. So if you are able to ping, that means it is good, that we are able to reach to the router gateway. If we are not able to reach, then we'll troubleshoot it further after some time. So anyhow, my packets are not reaching to this interface, that is fast Ethernet 0/0. So it may be, this packet may be dropping on this interface. So let me check the configuration of fast Ethernet 1/3. So what is the configuration? It is up, and by default it is in VLAN 1. What I can do here, say suppose on interface VLAN 1, I can assign one IP address something like 1.10 no shut, and if I ping to that PC that is in my local subnet, that is 192.168.1.11, and from here I can ping to my switch, local switch. It is telling that 1.11 destination host unreachable, and some undesirable results are coming. So I will troubleshoot this issue, that why from here I am not able to ping to this host afterwards. First of all, let me do the other things. So let me re-verify what is the IP here. IP is 192.168.1.11. This IP is perfectly fine, but still I am not able to ping to this switch. I will verify that after some time. Let me go and let me do other things first. So first of all, I want to show you captures inside ASA Firewall, and then I'll come to the other issues. In ASA Firewall, it's very easy to take captures. For that, what you have to do, you have to create one access list, means for which particular traffic you want to take capture. This is true with ASR routers as well. So ASR routers, the same way you can take captures, means the same way you can create access list. So in case of ASR routers, you can create ACL. In case of ASA Firewall, you can create ACL. In case of Nexus also, you can create ACL. In case of 6500 as well, you can create ACLs and map your traffics. Let me go to the ASA Firewall first, and let me show you that capture. So in this case, what I will do, I will create access list with respect to 1111 and 2222. That is the loopbacks for inside and the outside. So I am going to create one access list. You can give any name. So suppose loopback capture is the name, and I want to capture IP related traffic. My source permit IP, and my source is something 1111, and my destination is something 2222. Now what we can do here, because we want to capture this traffic both ways, going in to out and out to in, so you can give this a statement like this as well. So source to destination and destination to source. That means if I do so, access list, show run access list will give you the configuration. Then you can see here I have one access list, loop cap, source to destination or destination to source. Now in the ASA firewall, my loopback is somewhere here 1111, and my destination is somewhere here 22222. I'm going to send packet. Obviously it will come from inside zone to outside zone. So this is capture with the statement number 1, and the return traffic, that is the echo reply, will be captured by the statement number 2. So that is the idea here. Now once I have this access list created, what I can do here, I can create a cap. So you have the option of capture, so you can use capture. Then you can give the name, suppose cap. Access list is what? So our access list is something loop cap. Now you have other options as well at all the points. So buffer, circular buffer, ether type, interface. If you haven't created the access list, you have to do the same thing, like you have to define the interfaces or IP addresses, and you can do the same thing. Okay? So in my case, what is my interface? My interface is nothing but this interface, E0/1. So my interface is, it will tell you, my interface is outside interface. Here I can click enter and it will do its work. But if I want, I can give packet length, let it be default. Okay, so you can see here only one line statement. So capture is what? Cap. This is the access list, interface outside, and that's it. Now if you want to check that, you can type show capture cap, and you have options. So dump, you know what does it mean? Dump means you want the hex values, then you have the detail, then you have the count, access list, everything. If you click here, it is showing that it's still at the moment I am not sending any traffic. So what I can do here, I can send some interesting traffic from source to destination. So let me go to the empty putty, and I'm already on the empty putty. Let me go to the GNS. So from here I'm going to initiate the traffic. So from R1 I'm going to initiate the traffic. Let me send some few packets. So let me send only 2 packets. Okay, and let me check inside ASA firewall. See, 2 packets. So 2 packet means I'm sending echo request, I'm getting echo reply, I'm sending echo request, I'm getting echo reply. So what does it mean? It means that firewall is telling that I am not blocking the traffic. I am sending the echo request, I am getting the echo reply. This is the same case I got 2-3 days back, where the customers, they have some ASA firewall that is connected with the Nexus, and that is connected with outside 243. So what we are able to see, suppose some IP something like XXYY1, we are not able to reach to this IP. Means the customer, they are complaining that my server something like 10.1.1.10 is not able to reach the other side server something xx.1.243. and they are asking why we are not able to reach. So we have take captures on ASA Firewall, on Nexus. ASA Firewall was sending the echo request, but it was not getting the echo reply. My Nexus was sending the packets, and likewise it is not getting the reply packets. So we are able to send the echo request, but we are not able to get the echo reply. That directly means that you are sending the packets, means you have the route from A to B, but you don't have the return route from B to A. Once we created a static route from B to A, issue got resolved. Okay, so if you are sending the echo request but you are not getting the echo reply, that means you don't have return traffic. Okay, so in this case we have the return traffic, and this way you can capture the traffic. If you have issues with other application as well, so we can take the capture with other application as well. Suppose if you want to take capture with respect to TCP, so what you can do, simply you can go on this static route. I will cover in the routing section, but it's very easy. The command is very easy to create a static route. Say you have router here, you have router here. Well, this is 10.1.1.0. Here you have loopback this, here you have loopback this. So in this case you have three different network, 1, 10 and 22222. Suppose this is /32, this is /32. If you want to create a static route on R1, what you can do, you can type IP route where you want to reach. I want to reach 222. Means you have to give your destination, then you have to give the destination subnet mask. In my case, this is 255.255.255.255, 4 times 2555. So that is the destination subnet mask. And then you have to give the gateway. Suppose here your IP is 10.1, here is 10.2. So your gateway address should be 10.1.1.2. So this is the one-way traffic or one-way route you are creating. Means your ICMP echo will go in this direction. The same thing you have to create. This is configuration for R1. You have to create on R2. That on R2 you have to create IP route, and you want to reach to 111 with /32 of subnet mask, and your gateway is 10.1.1.1. So you have to create a return traffic route as well. Okay, but more will come in the routing class. Okay. So this way you can do. Now suppose if you want to do some captures with respect to TCP or some other things, you can do as well. So here you don't have that access. Even you can do that thing inside the access list. So you can create TCP based access list. Let me create one access list with respect to TCP based. I am permitting TCP to host suppose 1111, to host suppose 2222, and suppose equating telnet, that is 23. Now again same thing I can do in the reverse direction, 2222 host 1111 and equal to port number 23, that is telnet. Now I can create some other capture. So this time I can create capture something cap1, and if I check show capture cap1, I have to initiate the traffic. So what I can do here on the R2 side, I have to create, or I have to open port with respect to 43, or I have to enable the service for telnet. So for that, what you can do, you can enable password something like Cisco, then you have to go to line VTY. There again you have to give some password and login. So at least this much configuration you have to do if you want to do the telnet. Now from this device, that is the R1, and R1 I close, I think. So from R1 I can do the telnet and I can check that. So let me go to the here. I can double click on R1, it will come up. So R1 I am telnetting to 22222 with the source interface of loopback 1. I will press enter here and then I will check the ASA firewall. So inside the ASA firewall I can check show cap1. See, you're able to capture the telnet traffic. So telnet traffic is very different than the normal traffic, and it is something like TCP based traffic. So if I ever take class on TCP, I'll tell you that how actually they do this process, how they create the TCP, that is transmission control block, how they are using the sequence number and the acknowledgement number, how they are using the ISN to send the SYN, all these things I can explain you, and how they are using the sliding window as well. But you can capture whatever traffic, whatever application traffic you want, you can capture inside the ASA firewall. Okay, that was the one thing for the today class. Now what I'm going to do, let me make this PC online and then we'll take some span on this R3. So what I am doing here now, that on this PC, this is not able to reach to this switch. Why he is not able to reach to this switch? Let us figure out. So I'll go to switch number R3, and switch number R3 I have created VLAN. By default that is under VLAN 1. So show IP interface brief. If I check the VLAN configuration and exclude unassigned, so it is showing that VLAN 1 is up, its IP is 1.10. That is the conflicting IP. So why I haven't got any dupe? Is this IP I am using somewhere? Let me check that. So here I am using 12, here I am using 1.1, here I am using 1.11. So this is not the duplicate IP. Okay, that's okay. If I check show VLAN, yeah, please.
We use that for the VLAN 1.
Yeah, 1.10 I am using for VLAN 1. That's correct. ID or VLAN switch in the iOS it's a bit different. ID is 1. So inside this 1/3, it is showing 1/3 inside this VLAN. Okay, 1/3. Even I have 1112 as well, that I make as a trunk. So show interface trunk. You can see that 1/1 and 1/2 the trunking is on. Native VLAN is 1. They're allowing all these 1000 VLANs. 1/3 interface F1/3. Okay, nothing is there on 1/3. Even this interface is up. So I can do one thing here on 1/3. I can make this as a switch port. That's the layer 2 port. I can go to VLAN 1. Already it is unshut, but it's okay. 1.11. I can check the status of that interface. If my firewall is blocking, I can check that. Let me go to the Open Network and Sharing Center and Windows Firewall. Everything is disabled. Turn off or on. Yeah. So firewall is off here at the moment. I'm not able to reach from this interface to this interface with the configuration of switch port in this virtual environment. So is there anything that I can do on 1/3?
It's a gateway issue. You have assigned the VLAN IP as a 1.10, but you have mentioned the gateway is 1.1. The PC is not understand the gateway. because the PC gateways must be VLAN IP.
If I'm using this switch as a layer 2 device, then
Now you are not using as a layer 2 device. Where is the where is VLAN interconnection?
okay.
On layer 3 switch.
Mhm.
You can change the gateway of the PC is 1.10, then it will be ping.
Okay. I got your point. So what you are telling that if we use VLAN as a gateway for the PC, it will ping. Okay. So that I don't want. I want to use this switch, as a layer 2 switch. So for that, what I can do?
So need to be the inter-VLAN connectivity on router. Then it will be ping. Must be assign the IP on a router.
So on router already I have IP address.
Where is VLAN interconnectivity?
On router this is L3 interface. It is connected with L2 interface. So yeah, okay. Tell me what you're telling.
Where is inter-VLAN routing? Not required in the if the old device is connected in the same VLAN, not required in inter-VLAN.
Okay.
But
okay. So this is in VLAN 1. That is the native VLAN.
Native VLAN.
Okay. So what you are telling that when a packet is coming with 1.11 with VLAN 1. And here I have IP on VLAN 1. Forget about the router for a moment. So, okay, so you are telling if I assign this PC as this gateway, it will work.
It will work.
Okay, and then suppose if I want to communicate from this PC to this router, then
it also works. Because it's part of VLAN 1. Router 1 is also part of VLAN 1.
Okay, that's good. Yeah. Okay, so let me do that change, and I'll come to this point as well, why it is not working. So suppose if it is not working, is there any way to take captures and see why it is not working? Is the ICMP is reaching here or other stuffs? We'll check that. So what I'm going to do here, I'm going to router number 3, or let me change the name, host number 3, and everything is fine there. So I'm going to the PC, and inside that PC I'm going to change the gateway. Let me go to the prop. Okay, so now it should ping because the gateway is local to the switch. It will take some time to converse. Let them converse, and we can check the spanning tree status as well for this interface. In routers it's a bit different. So show spanning tree. In the switch it will give the output, but in routers you have to check. So you can check the block ports. 1/3 is blocked. Interface fast Ethernet 1/3. VLAN 1 is blocking. So why, you can see here the port is in the blocking state. So why it is in the blocking state, I will come to the other point as well. So that means if it is in the blocking state, it will not ping, obviously, because it is in the blocking state. So why it is in the blocking state? So what it is telling, you can check here, VLAN 1 is blocking, cost is this, port priority is this. I don't think so we have any loop in a network, but still it is in the blocking state. What I can do here, I can go to, even I can check show interface 1/3. The interface is up. This is the BIA. Everything is fine. No output dope. Nothing is there. But spanning tree has blocked this port. The easiest way to check is the block port command. And if I do summary will give nothing here. So blocking, it is telling that one port is blocking inside VLAN 1. Okay, it is blocking. So due to some reason this port is in the blocking state, although I don't have any loop in a network or something like that, but still it is in blocking. So what I can do to make this port as a unblocking port, is there any way that I can make that? And this is the problem with the GNS, not in the real world problem you have. One slash 3 self loop, because it is telling that it is self looped, it is looped to itself, this port, and that's why now it is not in blocking state. Now it is in blocking. Why? Because it is looping itself. So the port is looping itself, so that's why it is in the blocking state. So let me do one thing. I have the capture option also. Let me close this. Let me choose some other interface. Interface, suppose 1/15. And conft interface f1/15, no shut, show a spanning tree. It will take some time to converge. So any port that is blocking, 1/3 was blocking, although we haven't enabled any port security. Show spanning tree interface f1/15. No spanning tree is available for this port. Okay, what I have done on this port, that I made this as a switch port, that is the layer 2 port. After that it was start blocking, but by default it should work. So by default it is in VLAN 1, so it should be working inside VLAN 1. That is not in this case, that is in the case of GNS. So I will do one thing. I will go to f1/15 and I will make this as a switch port, access VLAN 1. Now if I check this, and this is not the part of packet capturing. Okay.
Why?
This is the problem with the simulation. There is no real time problem, but still you can see that if you have issue, what are the parameters you can check. Okay, so interface f1/15, if I make this switch port no shut, even I can make this as switch port trunk encapsulation.1q, switch port mode trunk, and switch port trunk allowed VLAN as a 1, that is the default. So it will say bad VLAN, because by default 1 is allowed, because this is the native VLAN, so it's okay. Show run interface f1/15. So this is the configuration on this. If I take show a spanning tree on interface 1/15, no spanning tree info for the 1/5, actually 15. So for 15 also, it's the problem of the device, so please do not worry on this part. Let me go back. So my main thing was to show you how you can capture packet across ASA firewall. At the moment I'm not able to capture here on this particular switch, but yeah, what you can do, you can span the switch and you can take the capture. So how you're spanning the switch, you can do the span. It's very easy to do the span for the switch. So what interface you want to capture? Suppose 1/2. So this will be your source, and 1/15 where you have the Wireshark, that is your destination. So you can use something like monitor. Actually, you have to do it in the global configuration. So monitor session 1, your source is fast Ethernet. What is your source? 1/2. So your source is interface 1/2, and it will ask for the direction as well, RX or TX. By default, it will take both. Monitor session 1, your destination is interface fast Ethernet 1/15, and that's it. So it will start your span. Only 2-line command. Source, destination, that's it. So it will show you your configuration that this is related to source and this is related to destination. And in the old class, we have seen that how you can capture inside the iOS. So let me revise that as well, that how you can capture inside the iOS. That is a bit difficult than the normal use case. So inside iOS, you have to specify what is your buffer, what is your capture point, and what type of traffic you want to capture. Either it is a safe switch or the software switch. So inside the iOS, you have to use monitor. I think you have to do like this. Yeah. In this platform it will not capture. What platform is this? This is, I think, 2.9 series. So the configuration that I have shown you, you can use inside 7200. So this packet capturing things are different in all the images. So in this image also you have some capturing. So let me check what capture option we have. So monitor session, I can span. So as a layer 2 capture I can take, and other is monitor. I can use monitor process or something, traffic. Process, CPU. This will monitor the process. For any process you can monitor. So whenever you are typing something like so process CPU and sort it and exclude something 0.00, so at that time they are associated with some number. If you want to monitor only that number, so process CPU extended, and then it will ask for number. Suppose if you want to monitor 33, that is your process related to exec, enter. It will monitor that. This is for this monitoring, not for the capturing. Okay, so let me go back to our slides where we are using the capturing. So span, you have seen, for a span you have only two command, that you have to define your source, you have to define your destination, and you can take the span captures. Please go through all these things. The EtherAnalyzer and the NetDR I will cover in the next class. The ELAM captures I will cover in the specific Catalyst and the Nexus classes. But yeah, EtherAnalyzer I will cover in the next class. And NetDR is very, very easy, so I will cover this as well. It's very easy to take capture in 6500 with the help of NetDR. I will cover this EtherAnalyzer in the next class with one use case. So yeah, VeloCloud I covered today, that you can create access list and you can apply to the ASA firewall, or maybe you can apply to the ASR routers as well. ELAM I'm going to cover in the specific hardware class. So ELAM, even in this particular presentation, they have shown very less ELAM commands, but I will take in detail. And then we have some real life problems. So tomorrow I'm going to cover NetDR, EtherAnalyzer, and some real world problem. That suppose your call manager is booting, or your phone is rebooting all the time, or you have some sort of latency in your network. You are finding that the network is very, very slow. So these type of use cases, I will cover in the next class. So for today's class, this was all. If you have, this is the packet capture, actually class number 5, and in the series this is packet capture number 4. Today I am going to discuss two important packet capturing tool. One is NetDR, and it's very easy to capture inside 6500, and other one is EtherAnalyzer. But the most important thing that I am going to discuss today is the use case. So when you combine all those packet capturing things, all those packet capturing methodologies, like in switches you have a span, you can take a span capture in switch. In routers you can simply export that captures. So 7200 or ASR routers or 4500, you can take captures, you can export those. In 6500, that is the catalyst switch, again you have option to export the capture, but if you are on critical, or if you are in the severity cases, at that time what you can do, you can debug NetDR and you can get approx 4K packets to analyze why it is like this. 7K platform is bit packet capture friendly because you have options of EtherAnalyzer, plus in 6K and 7K you can do ELAM capture. ELAM capture will come in the upcoming classes. From next class onward I am going to start 6500, and it will go for 15 to 20 sessions. So inside 6500 I will cover ELAM, and once I start Nexus 7K, then inside Nexus 7K again I will capture that ELAM. Again I will record some ELAM session now. Why? Because to understand this ELAM, embedded packet capturing or analyzing tool, you must know the hardware architecture. So how the ASICs are built, what types of ASICs are there, what are the forwarding engines, etc. So that's why. Let me go and let me start with the PPTs or the Cisco Live document. Now it's very easy to take NetDR inside the catalyst switch, and actually it's very easy to take EtherAnalyzer as well inside the Nexus. How you can take the EtherAnalyzer with help of D capture or C capture, that is the display capture or capture filters. So you have actually these two filters you have in the Wireshark as well. Suppose I am here in the Wireshark that we took in the previous session. If I clear this counter, if I want to filter with respect to suppose IPv4 address, or with respect to some let us take this DSCP, differential service code point. What you can do, right click on any of the packet, go to apply filter and select it. So if you use that filter, what the capture will do, it will show you that IP.DSCP field equal to 0. So whatever packets with has DSCP field as 0, you have here in the display filter. This type of filtering is robust. This is the display filter. Here you can see eth.address equal to this. So whatever MAC addresses will start with this, your packet will capture that. So suppose if I want to filter with respect to IP address, how I can do that? I can go to the raw packet where I have the MAC addresses. So let me go to any of the packets, suppose this ICMP packet. In the ICMP packet, you have to right click on the MAC address. If you know the MAC address, then it's very easy. Then you have to type something like dot address. So dot address and then equal, and whatever MAC address is there, you have to type it manually. If you don't know the MAC address, still you want to filter, go to any of the packet, check what is the MAC address inside that packet, and then right click and you can filter with a packet. So here I'm not able to see any MAC address, so I will get that MAC address in the ARP counter. Clear it. I don't have any ARP packet. Let me scroll down and check, do I have any MAC address here in any of the field. Let me double click here and we can expand all the packets. So in the frame we don't have MAC address. So what we can do here in this case, that we can filter with respect to IP address. So what you can do, you go to the IP field. So here you have the IP address. So right click here, apply a filter and select it. Suppose you can type like this, IP address and equal to 192.168.1.1. Apply. So if you apply that, you will get packets only which has IP address 1.1. This is the display filter. You can filter inside the Wireshark. The same display filter or capture filter you can use inside the Nexus switch as well when you are doing the EtherAnalyzer. The command is very easy to do. The EtherAnalyzer, what you have to do, that you have to start with the keyword that is the EtherAnalyzer. So EtherAnalyzer, local interface in-band. Then you have inbound high or low. So here you have some options that you have to check. If you want, you can use display filter. If you don't want, please do not use the display filter. And there is one very good document inside Cisco where you have all such type of filters that you can use. Let me show you that file inside the Cisco doc. So you can make some sort of template for all the capture files. Let me open one. EtherAnalyzer Nexus template. And even you have various blogs as well. So if you want to check some notes, what you can do, you can use blog EtherAnalyzer Nexus. You will get third or fourth hit, you will get some very good blogs. So here this blog we can check and this blog we can check. Okay. So in this particular blog, you have packet capture with respect to 3850, then embedded packet capture with ASR. Then you have the EtherAnalyzer. For EtherAnalyzer, it is telling that you can go to this link. So whoever the writer here for this blog, some guy, he's telling that from here he took this information. So control data plane, how you can capture, you can create one access list and you can apply in this format. Okay? So the simple thing is to use this EtherAnalyzer is EtherAnalyzer local interface in band. Okay, if you want to use some capture filter, you can use it. So whatever source, whatever destination, you can use it. I will show you today that how you can use the things, and you can write those inside the boot flash. So it is writing inside the boot flash, and once you write inside the boot flash, after that you can verify it. So these links you can refer. You will get good document plus the Cisco link. Cisco link, I'll show you that link as well. This is the EtherAnalyzer for Cisco site, and you can click and you can get those filters. Okay, but our document is also very good. You can refer that document as well. Now, this particular section, it's better to understand via example. So before I'm moving to the example, you can see here in 6500 platform, The capturing is fairly easy. What you have to do, debug netdr capture. If you want, you can use both, or RX or TX, and then you can check show netdr capture packet. Now I will come to the specifics of all these information in the upcoming class. Let us focus only on the EtherAnalyzer at the moment. Now this is one real world example I want to show you here in this example. What is the issue here? That slow download rate. I have server, I have client, and client is complaining. So this is the client. In the same VLAN, I have one server. Client is complaining that whenever I am downloading, my download speed is very, very slow. So how could I verify that actually why the download speed is slow, and what is the root cause for that, and what is the solution for that? So for that, what we can do, we can take some captures, and how this particular EtherAnalyzer will help you in this download case, in this slow download rate. So whenever you are using EtherAnalyzer, actually whenever you are using captures, it's very important to specify source and destination. So what is the source? What is the destination? It's very important. So suppose in this particular Nexus box, I am using this EtherAnalyzer local interface in band, and then you can use capture filter and then the host. So either you can use the client IP or you can use the server IP, no problem on that. So this is the statement for EtherAnalyzer. Now it's very easy. 3 keywords you have to use in the start. So EtherAnalyzer local interface, then this is the main keyword, that is the in-band, and then you can use the capture filters. That I want to capture traffic with respect to 75.155 or 72.155. There must be some. So you may capture in-band or you may capture outbound. So you may have out-band, that is traffic is going in this direction. You may have in-band, that traffic is going towards the Nexus. So this is the direction, either in or out. That's it. Okay. So here you can see the explanation as well. So N7K capture interface is either management or in-band. So you can see here either it will do the management or in-band. If traffic is software switched, it would be seen in the in-band. So if traffic is software switched, that is if the traffic is going towards CPU, it will be in-band. But yeah, in the in-band also you have options. So let me show you that option as well. So yeah, here you can see here the summary of the in-band command. So after in-band, if I type question mark, what are the options I have? I can use capture filter, I can use this, I can use this, I can use display filter. So in-band is something like that packet is going towards CPU, and you can use either decap, so decap filter, or you can use ccap filter. Generally we are using this capture filter. So capture filter or display filter you can use. Okay, apart from that, what are the other options we have? So limit captured frame, we can limit the size of the frame and limit the frame size. So these two things we can do. If we want hex value, with this we can use in-band raw keyword. So these are the options. Okay. let me go back to the slide. Okay, so in-band is CPU generated traffic, and you can refer this document as well. If you type in-band detail, you will get the detail option. So you don't need any access list, or you don't need anything. Whatever things are coming to the CPU, you will get in this filter. You can use display filter or capture filter. So in my example, I'm using this capture filter. So EtherAnalyzer local interface in-band capture, and then you can use the host. If you want, you can limit the frame size. Limit capture frame is 5, so it will capture only 5. If you want to write this information in the boot flash, you can use the boot flash keyword. So write inside the boot flash. So in future you can download to TFTP and you can check inside the Wireshark. There are other options as well. These are the capture filters. So what are the things you can use inside the capture filter? If you want to capture with respect to port, you can use the port, etc. Okay, so let me go back here in our slide. So what I am doing, I am capturing the CPU generated traffic towards this host, and once we'll do that, what output you will get. So check here that I am using this keyword, that is 7272, that is the host. I'm capturing the packet. What this output is showing, that all the traffic from the server 7272 or maybe host is being software switched. Why? Because in this capture it is showing this IP 72.155. Now 72.155 is what? 72.155. What is the VLAN IP? We'll check that. 72.155 is the client. Okay, 7272 is my server. Okay, so what this capture is telling, that you have Nexus switch here, you have one client, suppose 10, you have one server, suppose 20, you are capturing in band. That means if you are able to capture this packet in band, that means the packets are software switched. Okay, that's okay. Let me move down. So if you want, you can limit a capture to one packet, and if you want to show that, if you want to see that, you can use this command, and you're seeing that, oh, it is software switched. Now if a packet is software switched, it's very important to understand that how the Nexus or other line card works. So you have something called software, you have something called hardware. So first packet will go via software, via supervisor engine. Then that program will be again, that same program, the supervisor engine will write to the line card. So next consequent packet will not go via software unless you have something like ACL log key is there. So that means it is showing that all the time, whenever the new frame is coming, all the time the supervisor engine or the software is involved, and why he is involved. So that is the main question here. So why all the packets are going towards the CPU? Now the answer is, here you can see the server subnet mask is incorrect and it is /25 instead of 24. So everywhere the subnet mask is 24, but by mistake, due to some configuration mistake, it is 25. That means 25 means your subnet mask is something like 128. So whenever a client is requesting to the Nexus switch is sending that packet to server, and Nexus switch have to program that frame inside its software because they are in the wrong subnet. Okay, so that's why this path is software switched. First thing, that is the configuration mistake. Other thing, it's very important to configure no IP redirects inside the SVIs. So sometimes you'll get cases like the high CPU or the latency, generally latency. So you have latency issue, means users are not able to open HTTPS or HTTP sites. You will find that on those VLANs, IP redirect is default. So what you have to do, you have to disable IP redirects, means you have to enable no IP redirects. That is the Cisco recommended, and it's a big thing, this no IP redirects. So if we are getting cases related to related to latency, first of all you have to check this thing is there or not. So you have to give this command along with some other commands as well, like no IP unreachables, no IP redirects, no maybe proxy, no IP proxy ARP, like these 3-4 commands you have to check. But this is the top. So in the SVI you have to enable this. So in this packet capturing, what we understand that I capture the packet in band, that is the software switch. So whenever the packet is going across, they are forwarded by the CPU. So that's why there was huge latency in the network. Sometimes you'll get such type of case. I'm going to stop here for a moment. If you have any doubt, you can ask, then I'll recording. Now the second use case is really very interesting that I'm going to cover. VACL capture, we have already done that, so skip this. ELAM I'll cover in the specific classes for 7K and 6K. Okay, I'll cover that ELAM, no problem. Okay. One use case is here that is very important, and that's why we gathered today here. So what is that use case? VoIP phone reset. Now the topology is like this. So the problem is this, that this IP phone here with the access switch, it reset itself all the time, or you have latency in a network. So whenever you are making calls, the calls are of very bad, poor quality, like that. So how you can track that, what is the issue in the network, why the call quality is poor, why the VoIP phone start resetting itself, what is the issue? Now, so you can see what is the IP for this switch, and the diagram is something like that. You have IP phone, and IP phone is connected with PC. So you have voice and you have data VLANs. So you have two separate VLAN with this particular IP phone, and how could you track that, why the IP phone is not responding or why the voice quality is poor? Now if we solve this particular case, then we are able to solve 10 more, because in this particular case, this particular example, you will get so many mixed technology. As you can see here, that you have ASR router, you have 7200 router, you have call manager, you have VSS box, you have 3560, then you have IP phone. So it's complete, what you can say, the data center. Suppose these are the two data center 1, data center 2, or suppose this is one head office and these are the branch offices. It's like such type of environment, and you are running MPLS. So over MPLS service, you have headquarter and the branch offices connected, and in the headquarter you have this issue, or maybe the phone. Okay, maybe you have some other branch as well where you have phone and you're still on that phone you have issue. Okay, so this is the call manager from where the phone is getting the image. So the boot up process is via this. Maybe they are using SIP as a protocol. Okay, so let us see this, how the flow work. What you will do if phone is resetting, you don't have any clue what you have done. You reset the phone for 3-4 times, and every time you reset the phone you have the same issue. Now you can't reload all the switches in a network. Suppose if you are suspecting some hardware issue, what you will do? Okay, reload the box, upgrade the IOS. You have done all those things, still you have the issue. So how could you troubleshoot this case? Now for troubleshooting, it's very important that you have one source and you must have one destination. In this case, you can see here you have this access list created here with one source and destination. So destination is your call manager 12.10, source is your 10.22. actually some mistyping or misprinting is there. Suppose with this phone I have one PC connected. For that PC I have IP address 101.22. Okay, the source is 22, destination is 10, vice versa. So I can capture the packets in both directions, source to destination and destination to source. In ASR router, it's very easy to configure the packet captures things. So you can see in ASR monitor capture, this is the keyword in all the devices. Monitor capture ICMP cap, this is the name of the capture file. Interface WAN means the interface that is going towards WAN. Both, this is the access list. So what is the strategy here? The strategy is very easy to do capturing on all the interfaces. So what you can do, you can capture packets everywhere. You can capture packet here, 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 here. All the interfaces you can capture packets, so you can come to know that whatever X I am sending is X is received here or not. So if you are sending with X, you are receiving with X, means your network transactions are okay, means your end-to-end packet delivery is okay. So that is the strategy, to capture the packet on all the interfaces. So then only you come to know that is this VSS is dropping the packet, or ASR, or C7200, or you have issue with call manager. Because you don't have issue with call manager, why? Because other branches are getting IP addresses and no issue on the other branches. You have new deployment here in this branch and you have issue in this branch. Now, so you can do capture on ASR 7200. We have seen this in our previous sessions, that how you can do the captures and you can export these files. Now once you do the capture on these interfaces, then initiate the traffic. So from the switch, the traffic has been initiated, 25 times pings to the call manager, and you can see some of the packets are dropped. So I have initiated the traffic, I am sending 25 packets. Now I can verify the capture on the ASR interface and on the WAN interface. So on the ASR interface, monitor capture ICM export. If you want, you can export and you can check in the Wireshark. But here you have the output. So in the ASR, what he found that, okay, some packet drops are there on the ASR, but before that, let me show you something. If you type this command, show monitor capture ICMP cap buffer and filter with packets in buffer, I have 42 packet receive on this interface and 34 packet receive on this interface. So it's very important to understand this thing, that hey, I am sending, suppose from here I am sending 42 packets, and here I am getting 34 packets. That means the WAN is dropping some packets. So you can see here the difference in the packet count for the flow confirms there is a traffic loss through the WAN in the direction from the central office to the data center. So this CO to this DC, I have packet loss inside WAN cloud. So maybe we think, oh, WAN is faulty or something like that. So we have to log a call with the WAN. Let's see this. Now, if you check the individual interface with these commands like show interface gig00 output rate, even you can do one thing. You can change the load interval on the interface, and you can take the captures, or you can check the real-time traffic for the interval of 30 seconds. Here it is telling that, oh, ISP commits, the ISP CIR is only 100 Mbps. So what you are telling, or what you are getting here, that this WAN interface you are signed with CIR of 100 Mbps, or maybe suppose 50 Mbps, in this case 100. That means if you send some traffic, and if those traffics are not matching the 100 Mbps criteria, the traffic will be dropped on this interface. I want to pause here for a moment. Now in this case you can see that you can create this NetFlow entry. NetFlow entry creation is very easy. 3 parameters: record, so there are 3 parameters. So what are the parameters? Record, then export, and monitor. Inside monitor you are calling the record and the exporter. That's it. Now you can apply this flow monitor on the WAN interface. Why? So you can collect some statistics related to the traffic. So if you configure this on the router, then what this will do, this NetFlow, we'll check that. So the NetFlow, with the help of NetFlow, you will come to know that what type of traffics you have on that interface. Again, this is very easy to do this. There are other options as well that without creating NetFlow, you'll come to know that how you can track the traffic on that interfaces. You know that IP accounting or other things are there. You can do that. Now, once you do that NetFlow entry, you'll come to know that, oh, these are the traffics. The question is how we can export the traffic in the NetFlow. Say you have to give IP address for the destination. In this case, I am collecting on the device itself, but if you want to export, you have to give the export address, and for that, the same document you can refer the full configuration of the NetFlow. Let me show you the full configuration of NetFlow first, and then I will go back. So in the first example itself, we have discussed about the NetFlow, the overall configuration of NetFlow. So if you want to export to some destination, what you have to do, you can use, you can use the destination. In this case, I am collecting information on the device itself. You can use destination IP, and you can use destination port, that is the transport port. In this case, this is UDP. So this is the template you can use for any of the NetFlow configuration. Okay, it will work. You can apply on the multiple interfaces according to the flow exporter. So one exporter is mapped here, other exporter is mapped here, likewise. Let me go to the slide where we are discussing this thing. Okay. Let me go back. Okay. So here, with the help of this NetFlow or other tools, you'll come to know what are the traffic that is going egress to the ASR router. So in this ASR router, if you check the policy map on this interface, that is the WAN interface, here you can surprise with this. Oh, 0 packets are hitting for VoIP, 0 packets are for VoIP signaling. That means, although I have configured the VoIP, the QoS parameters on the ASR router, and I have applied that, but still the traffic is not hitting the QoS. So you have done the classification marking, but the traffic and the prioritization for the bandwidth, but the traffic is not hitting the output interface. That is the WAN interface. Why it is not hitting that? Let us check that. So till here it's fine. Now we need to determine where the packets are getting remarked. First set is to validate the configuration on the access port. Next is to validate if the IP phone is sending signaling traffic marked or not. So for that, what you can do, you can check this interface configuration. If you check that configuration, this is required for IP phone, that you are sending DSCP marked traffic or not from the phone. So your DSCP trust marking is here. Actually your DSCP trust marking should be here on this interface. So we'll check that as well. So this configuration you needed on this interface. After that, now if you want to see that you have done marking, now this is again very important to check that. So you have done some marking, DSCP marking here, and either the packet when it is hitting the switch, in that packet do you have the this DSCP marking? So if you want to check that, you have to span this switch. So once you span the switch, you have to do a span capture, or actually you have two options. So second option is recommended here. So second option is CLI on 3560 and check the QoS statics. So if you check the QoS statics, you will come to know this is the configuration for QoS. Means in this switch you have enabled the MLS QoS settings. So if you check here, so MLS QoS interface gig 0/1 stats, come to know that this particular queue, actually this is the DSCP. Generally for voice traffic we are giving expedite forwarding, that is the EF marking for VoIP or voice traffic. This is something 46 in number. So you'll come to know that it is hitting 46 here. Means I am sending marked traffic to the switch. Now how the switch is sending to the VSS box, that is the second check. So if you check that, now I will come and cover this ELAM in the upcoming class. So please do not worry on this case. But if you take the ELAM capture on 6500, on the Superman is nothing but the layer 2 engine. On the layer 2 engine with this source address, and this is the CUCM server IP, this source and this destination, you will come to know that are they coming, means the packets are coming with marking. So the packets are coming with the toss bit, that is the marking, but the switch is making that marking to 00. So you are sending some packet with something 46. So you have phone, you have access switch 3560, you have VSS box. So till this switch you are sending some packets like DSCP 46. Now switch VSS box, it is getting that marking with 46, but when it is sending out, it is sending with 00. That is the default value. That means if the default value will reach to the ASR and it will go to WAN, ASR will get packet with 00 marking and it will send by 00, so it will not use the QoS something like that. So let me show you that. So it is rewriting the marking at 00, the VSS box. Now let me scroll up. What you have to do for the solution, that in this switch as well you have to extend the trust boundary. So if you check the VO voice related documents, you'll come to know that whenever, actually there are 3 trust boundaries. So either your trust boundary is here or your trust boundary is here. Means it is local to switch, it is local to the first access switch, or is it local to the distribution switch. So you have 3 trust boundaries. In this case, because we are using QoS, so we have to extend our trust boundary till the VSS switch. So once we extend that trust boundary to the VSS switch, what you will find, MLS QoS trust, that the ASR routers, now they are getting the EF, expedite forwarding bits, and their queues are getting the packets. Now you don't have packet drops, and your VoIP traffic is now prioritized. So this is the question and this is the solution. You can come to know that, yeah, you solve 4 or 5 things here to solve this. But this is one of the frequent tickets that you will get, that you have issues with VoIP or IP phones. Okay, so IP phone call quality is not good, or it is not booting. So this may be the issue, that in the QoS field you haven't prioritized the IP phone traffic, or somewhere you haven't marked the trust boundary. So what the Nexus switches or the VSS box they are doing, they are unmarking the marking. So again you have to do the marking. So whenever layer 2 frame will ingress to the VSS box or the VPC box, you have to use that trust boundary, or you have to remark that traffic. So this is it for the packet capturing class. If you have any query, you can